Hi everyone, so this is a lesson on chapter 2.3 of the Year 2 Pure textbook, and this is on composite functions. Now this is a topic that you see at GCSE, so much of this chapter should be quite quick and easy for you, except we will be looking at functions, we will be including modulus functions in some of the work today, which is new to A-level. So, first let's just quickly get a definition of a composite function. So a composite function is when two or more functions are combined together to make a new function. And just to take note of this here, that if we have fg of x, that is essentially applying g to x. So we apply g first, and then we apply f to whatever we get from that. This is covered at GCSE, so this will be something that you know, that is just worth stating at the beginning of this lesson. So the textbook does have a kind of mapping diagram to show the application of a function, but I don't think that's completely necessary. You can have a look if you want to. It's on page 32. Okay, so we'll look at example 10 first of all. So example 10, we are given a function, so we're given f of x equals x squared, and we're given g of x equals x plus 1, and we want to firstly find fg of 1. fg of 1. So we're going to apply g first, so we want to find g of 1. First of all, so g of 1 would be 1 plus 1 is 2, and then we want to find f of 2. So we apply g first and then f. So f of 2 is 4. So fg of 1 is equal to 4. Part B wants us to find gf of 3. So first we'll find f of 3. So we apply f first, so f of 3 is equal to 9, and then we want to find g of 9, which is equal to 10. So gf of 3 is equal to 10. Nice and easy so far. And then part C wants us to find f of negative 2. This is sometimes written as f squared of negative 2. Later on in the book you'll see that. So we first want to find f of negative 2. So f of negative 2 would be 4. And then we want to find f of 4, which is 16. So f of negative 2, or f squared of negative 2, is equal to 16. So that's nice and easy. So we'll look at example 11 now. So example 11, we've got the functions f and g again, so f of x is given as 3x plus 2, and g of x is given as x squared plus 4. And we need to find various different composite functions. So part A wants us to find fg of x. So this means we apply g first, so g to x, so that would be x squared plus 4, and then we apply f to that. So we're going to be substituting all of g into the x that we see in f there. So we're going to have 3 multiplied by, so all of g is going to go into that, plus 2. Plus 2 is from the end of f of x, and then that gives us 3x squared plus 12 plus 2, so we have 3x squared plus 15. So fg of x is 3x squared plus 14. Part B wants us to find gf of x, and you'll see that these are not the same. They're not necessarily the same, they sometimes can be, but generally they're not. So this time we're going to be applying f and then substituting that into g. So G wants us to do x squared, which is going to be all of this squared, so it would be 3x plus 2 all squared and then plus 4, so we've put all of f into G there. So when we multiply out the brackets, we'll have 9x squared plus 6x plus 12x plus 4 plus 4, and that would be 9x squared plus 12x plus 8. So yeah, gf of x and fg of x are not the same thing. And part B, part C. So part C wants us to find the function f squared of x. So we're going to apply f twice. So that means f is 3x plus 2, but we're going to put f into that. Hopefully that makes sense. So we're going to have 9x plus 6 plus 2. So f squared x is 9x plus 8. And lastly, for part D, we need to find values of b such that fg of b equals 62. So we're first going to find fg of b. So that means I'm going to apply g to b first. So g of b is b squared plus 4, and then fg of b, so f of that is going to be 3 times b squared plus 4 plus 2. So fg b, I'm just going to underline this because that's what I was finding. Fg of b is equal to 3b squared plus 3 times 4 would be plus 12, plus 2 is 14, so plus 14. I could have used my function over here, fg of x, but I just wanted to do this question from the beginning. So next we're going to solve for fg of b equals 62, so that's the next step. So we have 3b squared plus 14, which is fg of b, make that equal to 62. And then it's just a case of solving from here. So if we subtract 14 from both sides and divide by 3, we get b squared equals 16. So b will be plus or minus 4. So the values of b such that fg of b equals 62, and b equals plus or minus 4. So after these two examples, I suggest that you go to the exercise 2C, which is on page 34, and have a go at questions 1 to 4, and then come back to the video. We'll do the next example, and then you can do the rest of the questions. Okay, so hopefully you had a go at questions 1 to 4 from the exercise, and we'll now do example 12 so that you can have a go at the rest of the questions. So example 12 gives us two functions. We are given f of x, and you'll notice in the textbook, this is on page 33, they're written in the form of f and then a colon, x and an arrow, but I just copy it down in the way that I'm used to, which is f of x equals. So f of x equals the modulus of 2x take away 8, so that's a modulus function, and then g of x is written as given as x plus 1 all over 2, and part A wants us to find fg of 3. So first I'll find g of 3 because I applied g first. So g of 3 is 3 plus 1, 4 over 2 is 2. And then f of 2 is the modulus of 2 times 2. Let's take away 8, isn't it? 2 times 2 take away 8. So that's the modulus of 4 take away 8, which is negative 4, which is 4. Because obviously we just take the positive numerical answer there. So fg of 3 equals 4. Maybe I should just write that up here. Kathy wants us to solve fg of x equals x. So we're first going to find, an expression for fg of x. We found fg of 3 in part A, but we need an expression for fg of x, so we can make that equal to x. So that means we're going to put all of g into f. So fg of x is going to be equal to the modulus. Now we're going to have 2 times x, but we're going to put g into there. So we're going to have 2 times x plus 1 all over 2, take away 8. This is quite nice because the 2 and the 2 cancel. So we get x plus 1 take away 8, which is x minus 7. So fg of x is equal to the modulus of x take away 7. Now we need to find, so we're going to start to solve now. We are asked to solve for fg of x equals x. Now if we think back to chapter 2.2, or was it even 2.1? 2.1 or 2.2? It was 2.1, wasn't it, when we did the modulus function? The way we would solve this is by using a graph to help us. So I'm going to plot y equals the modulus of x minus 7, and I'm going to plot y equals x. So draw myself some axes. Now y equals x is nice and easy. Just a nice amount in the middle. So that's y equals x. And then I need to plot y equals x minus 7, or the modulus of x minus 7. So that's going to have exactly the same gradient, isn't it? Both have a gradient of 1, but minus 7 means we're going to dip down here. And remember, as soon as we start to go into negatives, so below the x-axis, I use a dotted line because that's actually not part of the modulus function. And then there we go. So that's what that will look like. So we have y equals the modulus of x minus 7 here. And we can see that we only have one intersection point, which is there. And that is in the reflected part of the graph of y equals the modulus of x take away 7. So to find a, we have the reflected part of the modulus graph equals x. So that's minus x plus 7 equals x, which is 7 equals 2x. So x equals 3.5 or 7 over 2. And that's it. So you should be okay to carry on with the rest of the exercise now. And yeah, I'll see you next lesson.